Hello everyone. The last time we discussed functions, we said a function is a rule which assigns to each x value exactly one y value, and we went through and used we had little tables like this or illustrations. We also used ordered pairs. And we asked, are circles functions? No, the last time we did functions.
Oh, okay, you're right.
And we had the vertical line test. Today we're going to continue talking about functions. Remember we said we could use f of x in place of the letter y, and whatever number's in the parentheses, you plug it in for x, and that's how you get your y. Well, today we're going to start off by looking at a particular type of functions, something called a piecewise function. And there's not a lot for me to say before just jumping into an example. Let's look at problem 2 in this assignment. That's a really good first one. It looks sort of intimidating. It says for the piecewise function. A piecewise function is divided into pieces. Unlike the ones that we were looking at the last time, where there was just one little equation, like flip over here, flip back, h of x equals x plus 9, or f of x equals 5x squared minus 2x. Here there's just one rule, and these, let me write this one down. This is problem number 2. We have a piecewise function. Let's see.
Notice there are 3 pieces. You'll use the first piece if the x value you're plugging in is smaller than negative 3.
Okay, so h of x equals negative 5x minus 17 for x values less than negative 3. Okay. Now,
he's just still copying.
I'm just writing it down.
Okay.
H of x equals 2 for x's
between negative.
That less, when you see 2 less thans or 2 greater thans in the same statement, the fastest way to read that negative 3 less than or equal to x less than 2, just read that as between. H of x equals 2 for x's between negative 3 and positive 2.
Including negative 3, but not including 2.
And then h of x equals, what is that, x plus 8? I'm color coding this as I write it down. For x is greater than or equal to 2. There. Let's see. Okay, so we have 3 pieces. Oh, and that's just the function. I didn't even write down what we're told to do. Remember, with function notation, you...
h of negative 4.
Okay. We're told to find h of negative 4. The last time when we were working with functions, we said the number inside the parentheses is an x. In order to find y, you plug in the negative 4. But the question here is, which one do we plug them into? With every x, there can be only one y. We can't have both, or we can't have a black y, a red y, and a purple y. We can only have one y. How do I decide what's the y value that's paired with negative 4?
You substitute all the different equations?
You don't plug it into all of them. There's only one of them that you should plug it into. That's what this part over here is. We use the black rule for x values that are less than negative 3. Use the red rule for x's between negative 3 and 2. The purple rule for x's greater than or equal to 2. So where does this x value go? The first one, it's negative 4 is less than negative 3. So we're going to plug in the negative 4 into the black x. Negative 5 times x, I'm putting the negative 4 in for x, minus 17. Let's see, what's that going to be? We have a 20.
It'll be 3.
Minus 17, 3. So just like the last time, for every x, there's only one y, not two y's. We can't have a black and a red y. Just like, where's that problem? Look right here. We plug the 0 in, we got a 0. Only one y value.
Oh, Tony, that's
Oh, okay.
happening.
When you plug a negative 1 in, you get only one y value. For every x, only one y value. Was that one right, Tim? You said you've already typed it in? Of course. Now let's find h of negative 2.
The second one.
Okay, so negative 2 is between negative 3 and 2. Oh.
Yes.
It's negative 2 between negative 3 and positive 2.
Yes.
And so notice, there's not an x here with this red 2. This is what's called a constant function. The answer's just 2. Okay? There's no x that needs to be replaced. And what's h of positive 2?
Yeah, the last one, because it's greater than or equal to 2.
Okay. Ooh, my little equal sign here isn't very good, but hopefully you can see it. The x plus 8 is what you use for x is greater than or equal to 2. Now, if you had 1.99999, then you'd use the red rule, but you're using the black or the purple one. Is that going to be a 10?
Yeah, it's 10.
Replace the purple x with a 2. 2 plus 8 is 10.
So the first thing you have to decide is which piece is satisfied by the given x value. Now, h of 5. Is 5 less than negative 3? Is it between negative 3 and positive 2? Or is 5 greater than 2? Which one? So we're using the third piece again.
It'll be 13.
Ooh, you know what? Okay. And so, oh wait, and at 13?
Yep.
13. Just to make sure that it's clear. It looks like all I did was I used the first rule, then the second rule, then I used the last rule. Let me just make up one. Suppose we were trying to find h of 0.
It would be the second one because 0 is in between negative 3 and 2.
Exactly right. 0, it's not less than negative 3. It's not bigger than 2. It's between negative 3 and 2. So the answer would just be 2. What about h of negative 10 and h of positive 10?
Well, h of negative 10 would be the first one, which would be 50 minus 17, which is 33.
Okay, so negative 10 is less than negative 3. It's not between negative 3 and 2, and it's not bigger than 2. So it is that first one.
Then would be the purple rule, and that would be 10 plus 8 would be 18.
Perfect. So we have, let's see, what's that going to be? For h of negative 10, y'all are
50 minus 17 equals 33.
33, And for positive 10, what was that?
It was the purple one
Yeah.
because it's greater than 2, so x.
Is it clear how we're deciding which one to plug into?
Yes.
Okay? You do not plug into all of the pieces. You plug into only one piece. Any questions there? Well, we've done some graphing, and this is going to be some very, very good graph theory right now as we graph problem number 6. Oh, good. You can't see the multiple choice on here. Okay. Let me go ahead and write it down, and I think I'm going to use some of my graph paper. Number 6. F of x equals 2 plus 3x. Oh, whoever wrote this problem used the word if instead of for. I sort of like that. If x is less than -4, like -5, -6, -7, and so forth.
I think that makes more sense to do if you put the if instead of for.
For. I like the if better.
Yeah, because it's like for this, then plug it in for this. But if it's this answer, then plug it in instead.
So f of x equals -2x if x is between -4 and +5.
Or it could be equal to -4 or equal to -4.
Yeah, it could be equal to it also. And 2x if x is greater than 5. Okay, let me make sure I didn't miscopy it. Now, I'm using some graph paper. What I'm going to do first is set up my XY grid. I'm going to draw my y-axis. I hope y'all can see my little marks there. Okay, so I'm going to use just each little mark is one unit on this graph paper. And the first thing I'm going to do is decide where each one of these pieces is going to go. We're going to have 3 different graphs on here. We're going to have a black graph, a red graph, and a purple graph. All on this graph right here. Of course, y'all will be working in Pearson, it's all black and white, so you will just have it all just, But for mine, it's going to be different colors. And the way you go about this is sort of a process. You take the numbers over here on the right. I call those numbers cut points, because that's where it's cutting the graph, changing from the black to the red to the purple. And the first thing you should do is locate those cut points on the x-axis and label it. Okay, I'm going to locate -4 on the x-axis. 1, 2, 3, 4, -4. And what other cut point do we have? A +5. 1, 2, 3, 4, 5.
The x value can be any number in between and including -4 and 5.
I've moved the camera. Let me refocus this. Paste it. Okay, I don't know if that did any good or not. Okay. the black graph is going to be, well, first of all, maybe it'd be easier to do the red one. The red one is going to be between -4 and +5.
Including -4 and +5.
Okay, including. I'll make a point of that in a moment. But between -4 and +5, that's going to be this red graph. And I'm just going to write y equals rather than f of x. What I'm trying to say is between -4 and +5, we're going to graph y equals -2x. Now, for x is bigger than 5, what would we have for x is bigger than 5? The black one or the purple one?
Purple.
The purple one. I'll write y equals 2x right here. And I'm not sure why I'm doing the black one last. X is less than -4. That would be to the left of -4.
2 plus 3x.
The way we're going to graph these is to draw a little t-table, or xy table, whatever you want to call it, xy, and we're going to plot numbers right here. This is some very good graph theory. If you can graph this piecewise function, then you know an awful lot, or understand an awful lot about graphing. And x, y. Okay. At cut points, when we were solving inequalities with cut points, do you remember the way we had open and closed circles? And if so, for solution cut points, if there wasn't an equal sign on it, if we just had less than or greater than, did we use open circles or closed circles? Open. So at this black -4, we're going to have an open circle. Here, the red ones, both of those have equal signs. We're going to have a closed circle. At the purple here, at 5, we'll have an open circle. What the heck am I saying? Okay. Start off, we're going to graph this black piece. You start with the black cut point. Take the black -4 and plug it in. And if you're saying, wait a minute, it doesn't say x could equal -4. That's right. The way we'll take care of it is we're going to put an open circle at that point. At the cut points, you put open and closed circles, just like when you were solving inequalities with cut points. Plug a -4 in right here for the black x. 3 times -4 is -12. 2 plus -12, would that be -10? So locate the point. Left 4, down 10, put an open circle. It's going to seem strange until you've done enough of these. By the time we're over here on the purple one, it won't seem so difficult. But let me see. Go down 10. 1, 2, 4, 5, 6, 7, 8, 9, 10. Ooh, right there's -10. I better extend my... Is it even showing? No, barely. Let me lift this up a little more. I'm doing a... Okay, there. That's better. Okay. So at left 4, down 10, open circle. Now, we need another point. I should have mentioned this already, that each one of these pieces is a line. There's no exponent on it, so it's a line. So, we need another number to the left of -4. You could use -5, -6, -7, -8. Do not use -3, -2, -1. The black graph should only be with x values less than, or to the left of -4.
I think it might be best to do like -5.
That's what I'm going to use, -5. Now, the cut points are where you have open and closed circles. Everywhere else it'll just be a dot, which looks like a closed circle, doesn't it? Dot. So when I plug -5 in for x, 3 times -5 is -15.
So it would be
2 plus -15, is that -13?
Yeah.
So we go left 5, like 11, 12, 13. So left 5, down 13, just like that. And now I'm going to connect the open circle and the dot. Mm-hmm. Oh, the open and closed circle can only go at cut points. That's how it's going to indicate where the rules are starting and stopping. The open and closed circles, and this unfortunately looks like a circle, but it's just a dot. Okay? Dots go for numbers that aren't cut points. And the cut points, there's only 2 of them, -4 and +5. Because any time you plug in -4 or +5, you've got to indicate whether there's an equal sign with the open or closed circle. Okay? The -5 is not one of these cut points. So just a dot, and I'm going to connect these. Okay? So let me see how good I do. And one end is going to get an arrow. How do y'all think I'm going to draw this? Am I going to draw it up like this? Look how my pen's moving. Like that? Or would I continue it downward like this? Continue it downward. Why am I not drawing it up like that? Well, between -4 and 5, there shouldn't be a black graph. Between -4 and 5, there should be a red graph. Okay? Now, to graph the red graph, we have 2 red cut points, -4 and +5. On this one, you're not going to have any of those dots. You've got to plug in the cut points. That gets you the 2 points. And at each of these cut points, will it be open or closed? Closed because there's an equal sign on it. So I'll do that. Closed circle. Closed circle. So when I plug a -4 in for x, what am I getting for y? -4 times -2 is 8. So we have a closed circle at left 4, up 8. 1, 2, 3, 5, 6, 7, 8. Left 4, up 8, closed circle. And when I plug the 5 in, -10. Oh, yeah, so it's going to be a... Okay. Oh, if I had a ruler, I'd connect the dots and draw it, but let's see how I do how bad my line looks here. Or if you want to be technical and call it a line segment. There. Should I put arrows on it? The way I've drawn it, I stopped it at -4 and +5. No arrows. Should there be arrows on it? No. The red graph should only be between -4 and +5. Okay. Now, are there any questions? What about y equals 2x? That's the purple graph. Well, is there a purple cut point? Yeah, a 5. Purple 5. That's the cut point. Will this point have an open or closed circle there? Open circle. So when I plug a 5 in, do I get a 10? But we need another point. So I'll give y'all a choice. Which number do you think I'm going to plug in right now? A 6 or a 4? 6. It's got to be bigger than 5. This purple graph should only be to the right of 5. So if I plug a 6 in, that gives me a 12. And that's just a dot. By dot, I mean it's not a open or closed circle. Although my dots look like closed circles, don't they? So right 5 up 10. Ooh. Right 5 up 10. Open circle. Does that look terrible? And then right 6 up 12. 11, 12. Dot. Oh, I'm glad Tim's not here. If he saw that mess I just made, he'd be chastising me, telling me I should have moved the whole thing down further. And looking at it now, I should have. Okay? So it's this purple open circle and the purple dot. I'm going to connect those and put an arrow how? Going up or going down? Up. It's got to go. X is bigger than 5. The purple graph, if you put an arrow going this way, then it's down where the red graph is. In which case it wouldn't be a function because it wouldn't pass the vertical line test. Okay. Any questions there? Every year when I'm doing these, I wonder, does Pearson have one of those little graphing tools at this point, or is it just like these? And it's still multiple choice. Okay? Let's see. Gosh, looking at what I have, I'll blow up each of these. It is not that one, right? See, here's, okay. It should have piece, this line like that, and then the piece up there, okay? So it's definitely not A. Let me see, is it B? No. Is it C?
Yes.
That looks like it, okay? And if you want to count the little marks, it looks like each little mark on here is 2, because it goes all the way to 22. But I think it's this one. But let's just go ahead and make sure it's not D. No, it's not D, is it? Okay. You want me to look at it once again? Yes. There it is. I'm thinking it's graph C. I'll blow it up once more. Okay. So let me choose C. And check my answer. Okay. Any questions on that? You plug in the cut points. You need 2 numbers to plug in. And sometimes students say, well, wait a minute, it doesn't say equal to 5 there. Why are you plugging in the 5? You can think of it as me plugging in 5.000001. If I were going to plug that in, it'd look like 5, wouldn't it? And the way we're using the open and closed circles, on the purple piece, there's not an equal sign. Okay? On the red piece, that's where there's the equal sign on each of them. And on the black one, there's not an equal sign. That's why we have the open circle there. Okay? Are y'all ready to do another one? That's the one that has 3 pieces. The rest of them have only 2 pieces. If you can do a 3-piece one, you can do a 2-piece one. It'll be a lot easier. So let me write down problem 3. Let me get another sheet of graph paper. Problem 3. It says f of x equals x minus 1 if x is less than or equal to negative 2 and negative 3 if x is greater than negative 2. Okay, so I have a blue piece and a black piece. Red piece. Let me draw my x-axis and y-axis. Oh, here. Give everyone a sheet. Tim's going to give everyone a sheet of graph paper.
Do y'all want a piece of graph paper, or are you okay just freehanding it?
You're okay? You sure? You got graph paper? Okay. Oh, my mind went blank. Okay. We start off locating these cut points on the x-axis. Okay. And I have some colored markers up here, Tim, if you want to go and pass them out to everyone. And I'm joking about that. Okay.
I just like watching it.
Oh. We're going to have a blue part of a graph and a red part. And, it's just, oh, wow. Okay, Tim. Okay. So, really this would have been a good thing to have done for the one I just did, the messy one. Let's see, 1, 2. We start off by locating the cut point on the x-axis. There's only one cut point, negative 2. Now we're going to decide, where does the blue graph go? Is it going to be to the left of negative 2 or to the right of negative 2?
Where is the x-axis less than negative 2? I think it's to the left. I agree.
One semester I remember a student asking me, will it always be the way the symbol's pointing? And I said, yes, if x is on the left. It's always the way the symbol's pointing. The blue graph should be to the left of negative 2. So let's see if y'all got the hang of how we set this up. To the left of negative 2, I'll write y equals x minus 1. If you want to say f of x, that's fine. We draw an xy table, and you've got to plug in the blue cut point. And on the blue cut point, will there be an open or closed circle? Open or closed?
I heard someone say closed.
Oh, you did? Okay, I'm deaf. So I'm just setting it up. Now for the next one, for the red one is to the right of negative 2. See how the symbol's pointing? So we're going to graph y equals negative 3. I'll draw my xy axis.
table.
table. And we have a red cut point, which doesn't have an equal sign. So at that cut point, will it be an open or closed circle? Open. So now we get started. I'm going to go back to the blue one. Are y'all caught up? Are there any questions? We plug a -2 in for x. -2 minus 1 is -3. So left 2, down 3, closed circle. Then we need a number to the left of -2.
A number that's actually less than -2.
I'll give you a hint. Okay, -4. I was going to ask, do y'all want me to plug in -3 or -1? -4 is a good one to plug in. That's what I'm going to use. The important thing is don't plug in, for the blue one, don't plug in -1, 0, 1, 2, 3. Okay? The blue graph needs to be to the left of -2. So plugging in a -4, -4 minus 1, that's a -5. And what I'm about to put will look like a closed circle, but it's just a dot. Left 4, down 5. So let's see. Left 4, down 5, dot. Boy, they both look like closed circles, don't they? I'm going to connect them, and where does the arrow go? Is the arrow going to be pointing up or down? How am I going to draw it? Like this with the arrow, or like this?
Down.
Down.
You start at the cut point and go towards that secondary point that you chose yourself.
Mm-hmm. You start here and start going this way. Yeah, that's a good way of wording it.
You start at the cut point, you go to the secondary point. A word about the secondary points, the numbers that you choose. That is always just a regular closed dot. The only place you can have an open circle is when you're plugging in a cut point and there's no equality. Any secondary points that you choose on your own have to be regular closed dots.
Now we go to the next one. This is one of those constant functions. By that I mean there's no x to plug into. That means actually it's easier. What's the y value here? It tells you. Y is -3. So I'm going to go ahead and put a -3 there. And a -3 here because we have to have a number we've got to have 2 points.
What number do y'all want to use that's bigger than -2? Choose a secondary point.
4? Is that what I
I'll
heard?
use 0.
4, 0. I'll use 4.
So it's on the right side.
Okay. Something unusual is going to happen here. When I put an open circle at -2, 3, oh wow, there's already a circle there. A closed blue one. Since I have different colors, I can do this nicely. 4, oops, dot. You'll see what I'm trying to show here. I'm trying to show that with the red graph there's an open circle and the blue one a closed. I can do that when it's different colors, but y'all are living in a black and white world on Pearson. They don't have it color coded, and so
If an open and closed circle appear at the same spot, your graph will have a closed circle. That's what he's trying to say.
yes.
The closed circles take precedence. An open circle says that this point isn't on the graph, but wait a minute. Yes, it is. It's on the graph for the blue piece. So if
I
you
like
have
it like this, where there's 2 different colors, so you can see. But
But they're
that's
not going to show that.
They're not going
on
to
my
show it
math
like that.
class.
Yes, go on and show them. Let them see the choices.
Okay, hold on. I'm going to start popping them out. A, is that it? No.
Notice how it's all black and white, and so
B,
It could be.
it might be it. Let's see. It looks like they're incrementing in units of 2, 2, 4, 6, 8, 10. And that's 2. And then down, this might be it. Okay, let's keep that in mind. That's B. C,
No.
clearly
definitely
not. D,
No.
no. Okay, so response B. Check answer.
And X hat, and then blow it out once more. Notice what they did, just a closed circle, whereas, now show mine, I'm showing red and blue, but again, if
The
I had all
advantage
just
to
one,
this is looking at the graph, you know where the pieces change. It's clearly obvious that the pieces change there at -2. If you didn't have the equation, but they're not doing that in the
and they really can't with just one, black and
Color.
white.
I know.
Okay? Any questions there?
and
This assignment is called Piecewise and Quadratic Functions, and that's the piecewise stuff. Let's discuss quadratic functions now.
you want me to take over for a while?
If you
That's
want.
the voice?
Here, you want to put on the
Yeah,
microphone?
It'll
The microphone doesn't work when there's two of them going, okay? So that's why only one of us is wearing a microphone.
I'm perfectly fine talking loud, okay? I'm a loud talker. I'm a big writer, so, that doesn't bother me the least bit. But anyway, oh, Tony, is a microphone, but it doesn't have to stuff.
I think it's just do it your way. Okay?
Okay, so
Right quadratic
I know
function.
that. Switch over.
Oh, is it still recording? Yeah.
Okay, so now we're going to begin the second topic in this assignment, quadratic functions.
I think they've already graphed some quadratic functions. Remember
Using the three-point
three-point
quadratic tool, when we did that big graphing section, we used a three-point quadratic tool. But here we're going to get a more advanced graphing tool. It reminds me of the absolute value graphing tool that we saw. So, but I'm getting ahead of myself. We know quadratic expression has to have an x squared. The variable has to be squared. It can't have a cube on it, just a square. And I'll say that it's any equation that can be written in the form either y equals or f of x equals ax squared plus bx plus c. And remember I said a quadratic equation back in the fourth homework assignment, was it? Where I said that a quadratic equation was any equation that could be written in the form ax squared plus bx plus c equals 0. A quadratic function, the quadratic expression is set equal to either y or f of x. The graph of a quadratic function is a smooth U-shaped figure called a parabola. Parabola? Okay, you call it a parabola. It'll either open upward or downward. And I want to remind you of something. Oh, let's see. Where do we have? I want a piece of scratch paper. Here. You can have parabolas that are opening left or right. Don't write this down. It could open right or it could be opening to the left. But we only want to look at parabolas that are functions. Do I remember that vertical line test from the functions homework assignment? Those are not functions, so we don't have to worry about the horizontal parabolas. I refer to this as a horizontal parabola. What we'll be graphing will be vertical parabolas. Whether a parabola is opening upward or downward is determined by the leading coefficient. If the a value, the number in front of x squared, is positive, we expect the parabola to open upward. If the a value is negative, we expect the parabola to open downward.
That's only for A.
The a value will tell you whether it's opening upward or downward. Now, whether it's opening upward or downward, we're not going to... There's got to be a point where the graph changes directions. That point where the graph changes directions is called the vertex. Oh, wait a minute. I moved it up too far. And there's two different approaches for determining the location of a vertex, the vertex of a parabola. You can complete the square, which is never the quickest method, or you can use the axis formula, which is also the vertex formula. So I'll say axis or vertex formula. The vertex will always occur at the ordered pair with the x value equal to negative b over 2a. And it's an easy way. There's an easy way to remember that vertex or axis formula. It sort of starts to look like the quadratic formula. It's a negative b. It doesn't have all that messy plus minus square root of b squared minus 4ac all over 2a. It's just negative b on top and the 2a on the bottom. The axis is the imaginary vertical line that passes through the vertex around which the graph is symmetric. Notice this thing. If I drew a vertical line passing through the vertex, now if I took my paper and folded it down that vertical line, the right side should lie directly on top of the left side. They are symmetric. And this graphing tool of ours, what we're going to do, it reminds me of that absolute value graphing tool. You'll have to determine the vertex. You'll have to find one additional point, and then the graphing tool will use the symmetry to get a very nice graph drawn. Okay, let's see. The domain of a quadratic function is always the same thing. This reminds me of a problem from that functions assignment where they're asking us to find the domain, and it's a trinomial like this. There was no fractions and no square roots. When you're trying to find the domain of a function, you're trying to avoid two things: denominators of 0. You're trying to avoid square roots and negatives. Well, suppose you don't have any fractions and you don't have any square roots. What did we say the domain would be? Right, negative infinity to infinity. You can plug in any number you want to for the x values. You'll get a real number back for the y values. And when we're graphing these things, using the graphing tool, what you'll do is you'll find the vertex. I think did this thing just die out? No, it's still working.
Can y'all hear it?
Can y'all hear me? Can y'all hear me? Okay, so we'll use the negative b over 2a. The first thing we'll do is we'll find the vertex, and then we'll get a secondary point. Choose any number you want to, something that's easy to work with, though. So, well, I mean, we don't have a specific number function yet, so, but just, I'll say some other number. Some other number. And to illustrate, we are doing number Number 9.
It is done.
Yeah, I think
It's like
so.
popping in and out.
It's going in and out. Let me see.
Maybe it wants to be in the front pocket.
Well, the light's still on, so let's see. Number 9. Graph the quadratic function. They want us to give find the vertex, the axis, domain, and range. Realize the axis is this vertical line, x equals minus b over 2a. And the range, we'll have to look at the graph to determine the range, okay? And let's see. Before we start that, I want to make I'm going to mention something else that will be important when we look at the word problems in a moment. If the parabola is opening upward, the vertex is the lowest point on the graph. That means the vertex corresponds to the minimum y value. That's the lowest y value possible. So if a parabola opens upward, the vertex has the minimum y value, the smallest y value. Whereas if a parabola is opening downward, the vertex is the highest point on the graph. That means this point has the biggest y value on the graph. So this vertex would be the maximum y value. In a little bit, we'll be doing some application problems, and in all those applications, they're going to be wanting either the maximum or the minimum value of the function. That's what it'll all boil down to. And where does the max or minimum occur on a parabola? At the vertex. So my hint to you for these word problems that we're going to be doing in a little bit, use your vertex formula and determine the location of the vertex. But let's draw this graph. This is number 9. Number 9. Let me write it down. F of x is equal to negative 2x squared minus 20x minus 48. So they want us to find the vertex, axis, domain, and range. And we're drawing the graph. So let's switch it. There. So when I look at this function, I have an idea how the graph is going to look. Will it be opening upward, or is it going to open downward? Look at that number in front of x squared. The coefficient of x squared is negative, so what do we conclude about the shape of the graph? It's going to be opening downward. Okay, so I'll make a little note right here. I expect it to look like that when I draw my graph. Use the vertex formula. X equals negative b over 2a.
So it would be technically positive 20.
Okay, you have that green negative from the formula. The b value, it's just like with the quadratic formula, that b value is a negative 20. The opposite of negative 20 will become a positive 20. I agree.
And the bottom one would be 2 times negative 2.
2 times the a value is negative 2.
So that would translate to 20 over negative 4.
Which reduces to?
Negative 5.
Okay. So the vertex is going to be an ordered pair that occurs when x is negative 5. And let's make a note. That's going to be the vertex. Well, we know the x value. If you know the x value, how do you find the y value? What are we going to have to do to find that y value? plug in x. Remember, f of x is just a fancy way of saying y. So I'm going to do that. I'm going to plug that in right here. Y equals -2. Replace the x with -5. Minus 20. Replace the x with -5. Minus 48. -5 times -5. Remember your order of operations. You do the exponentiation first. -5 times -5 is 25 times -2. So we have a -50. -20 times -5 gives me +100 minus 48. Oh, this is going to give me a real nice y value.
Of 2.
I agree. -50 plus 100 is 50. Minus 48 gives me a 2. So my vertex occurs at the ordered pair -5, 2. Now we need another point. You know, what's my favorite number to plug in?
0.
0 is my favorite number to plug in because these things here don't plug in 0, though. You'll see why in a moment.
So it would be -48, since we know that whatever times 0 is 0.
That's right, but they're going to give us a grid in a moment to draw the graph. Do you think it's going to go 48 units down?
No.
I'm betting it isn't. So here's what I've found. Don't move more than 2 units away from the vertex location. So we have the vertex occurs when x is -5. So you could use -4 or -3, or you could use -6 or -7, but don't move further than 2 units. If you move too far away, you're going to get a y value that you're not going to be able to graph. So how about, what do y'all want to use? Maybe, well, -3? Y'all want to use -3? We're plugging in -3. So here's my work. I'm going to start plugging in -3. We have y equals -2 times -3 squared minus 20. Let me write it down first. Times -3 minus 48.
So the first one would be 9 times -2, which is -18.
Okay, I agree. -3 times -3 is +9. Times a -2 is -18. Okay.
20 times -3 is +60.
I agree there as well.
Minus 48.
So -18 plus 60. What is that? Is that a 32 or 42? That's a 42 minus 48.
So it'll be -6.
So there's my secondary order pair. And let's see, what all do they want us to type in? Let's see. They want the vertex, axis, domain, and range. The vertex, that's that x equals. No, I mean not the x equals, that's the axis. The vertex, we're typing as an order pair. That's the first order pair on that table. That was, what was it? -5, comma 2. Okay, check answer. Now we're drawing the graph, so let's pop the graph out. And this is no longer that 3-point graphing tool that we used a couple of weeks ago. I see one thing that looks like a vertical parabola. There it is, the vertical parabola tool. So we click that. And the first thing they say to do is to plot plot the vertex. The vertex was what? Negative 5, what did y'all say? Negative 5, 2? Okay. Notice I'm looking at that ordered pair up in the yellow box. I can't really count those little increments that were jammed in so closely. So there's negative 5, 2. And notice, now it says plot another point. As I move around, notice it's drawing every parabola possible that has a vertex of negative 5, 2. And the secondary point we got was negative 3.
Negative 6.
Okay, negative 3. Oh. Well, shoot. Oh, I almost had it. There. Is that the point I wanted? Negative 3, negative 6?
Yes.
Y'all see where I'm looking? Y'all never act like y'all see that the coordinates there, but I can't move my hand. I can't move the mouse to show y'all because then I'll move the point. But y'all see there in the blue box where it says negative 3, negative 6, correct? I mean the yellow box. The yellow box.
You're good.
Okay, click, save. Notice it's all there. Oh, and you'll notice if we had used 0, which is my favorite number to plug in, we would have gotten a negative 48. Would we have been able to go down 48 units?
No.
No. That's why I say don't move more than 2 units from the location of the vertex. Now the axis is that x equals. It's a vertical line, and remember equations of vertical lines have an x and no y. The axis is x equals negative 5.
So it should be the same as the vertex.
It's that vertex formula, but they want you to write it as an equation, x equals negative 5. Okay. The domain. I know the domain. I don't have to look at anything. When I wrote the problem down, no fractions, no square roots, all quadratic functions have the same domain. What is it? Okay, all real numbers. Negative infinity, comma, infinity.
You didn't put negative infinity.
Just
Thank
put
you.
positive and positive.
Negative there. Okay. I think I was distracted. Since when did they put the plus minus buttons down here? Have they always had those?
No, that's new.
Oh, okay. I wonder why they decided to put them there now. Now the range. The range, you have to look at the graph, okay? Let's look at this graph. Let me see something else. I'm going to pop it out. There it is.
That one looks
Is the
good.
vertex corresponding to a maximum or minimum? It's a maximum. The vertex is the highest point on the graph. What is that highest y value? It's hard to look at that, isn't it? But we know what it is because when we found the vertex, what was the y coordinate? 2. And so the biggest y value on the graph is 2. And then I claim every number underneath 2 is used as a y value, correct?
Yes.
Every number under there. So how would we say that? The range is...
Y is less than or equal to 2.
Okay, so the range... Okay, I agree that all the y values are less than or equal to 2, but they want us to say that using interval notation. So, how would we express that? Looking at the graph, all the y values, the biggest y value is 2, and then everything less than 2. Using interval notation, remember you go small to big.
So would you do 2 to negative infinity?
Is 2 the big one? I think, what's bigger, 2 or negative infinity?
Oh, so negative infinity to 2.
Correct. Negative, did y'all follow her logic there? With interval notation, it has to go small to big. 2 is being used at the vertex. We have a point that has a y coordinate of 2. So we would put a bracket after the 2. So, back over here, to determine the range, you have to look at the graph, and it helps me to think, is the vertex corresponding to a maximum or minimum? If it's a maximum, then it'll be negative infinity up to the y-coordinate of the vertex. If it's a minimum, it'll be the y-coordinate of the vertex up to positive infinity. And that's a good generalization I'll write down in a minute. So it's negative infinity, comma. What is going on? I clicked that negative. Maybe that's why they had negative infinity, comma, 2, bracket. While we're thinking about maximums and minimums, I think it might be helpful, maybe not, but I think we can make a generalization. Okay. Here's a parabola opening upward. Oh, that's not a very good picture of a parabola, but it's good enough for our purposes. Now, I just know that long hair is not mine, so I don't know where it came from. Okay. Let's suppose this vertex, I'm just going to say the vertex is located at the ordered pair AB. There's the ordered pair AB. We know the domain is always all real numbers. For the range, if the parabola is opening upward, then the smallest y value is b, and then all the other numbers bigger than b are used. So I'll say bracket b to infinity. Here's the one that we just looked at. The parabola is opening downward. Oh, I don't know if I should be using A and B because that then messes up my ABC stuff there. So, well, it's too late. Whatever that number is, this y value here, B, I'll say the range. I'll use this color. This number B is the biggest number on the y-axis, the biggest y-coordinate, and then every number underneath it. So that's the one, negative infinity, comma, B bracket. That's what we just saw with number 9. If you're working with a quadratic function and you're asked to find a maximum or a minimum, where should you start thinking they're going to occur? If the parabola is opening upward, where does the minimum occur?
At the point.
Okay, at that point you mean the vertex, okay? If it's opening downward,
The vertex is a minimum, or is the maximum?
the vertex is a maximum. That brings up another idea. Okay, so this thing is a maximum here. And you said this one here is a minimum.
It's because for it being negative infinity, comma b, that's the highest number. But for b, comma infinity, that's the smallest number.
Okay. What about the, very well said, Jacob. What about the maximum? Here, you say there's a minimum at the vertex. The parabola is opening upward. What would the maximum be? Is there a maximum y value?
There's no specific maximum.
There's no maximum y value because you see those arrows, it keeps going up and up. So I'll make a note here. If the parabola is opening upward, there's no maximum. Now, if the parabola is opening downward, you said the maximum occurred at the vertex. Where's the minimum? Is there a minimum? No. So, okay. And we have some word problems we want to do. First. Oh, I like this one. Oh, what?
Really easy.
Well, I guess Okay.
It's hard to tell that that's a negative 8, isn't
Oh,
it?
wait. Let me see. Read.
The figure shows the graph of a quadratic function y equals f of x. Use it to find the minimum value of y.
Well, it says f
Of the
of
minimum value of f of x. I see f of x and just read it as y automatically.
Isn't it like the minimum 8?
Yeah, it would just be 8 because of the fact that that's the lowest number for the y-axis.
That's correct. The smallest y value on that blue graph is positive 8. The value of the function is the y-coordinate, not the x-coordinate. And it's hard to tell that that's a negative 8, comma 8. But it has to be.
Yeah.
I guess the negative is part of that line there. But any questions? The minimum y value on this graph is positive 8. Any questions there? Okay, number 11.
Is this the first word problem this semester?
Yes. It is.
Say yes, Tim.
Yes?
I think it is.
I'm just realizing this was what we were doing there in March of 2020. I'd been gone for 2 months being radiated for my cancer, and I came back, and it was like the Wednesday before spring break, and it was
This
my
was the
first...
Monday before spring break.
The Monday before spring break? Oh, well, what did we do the Wednesday before?
Fog and golf. It's the
Oh,
last
so
one.
this wasn't... So this
is
wasn't...
the one that you decided, oh, we have so much time, let's do more problems. And I remember the students. That's when they stopped liking you, Tim.
They were liking me. I was back. I had taught class, you know. I'd been gone on sick leave, and they were really enjoying the class. I think they were, until it dawned on me. Tony was wrapping up. He'd finished the lecture and stuff, and I was like, well, there's still 40 minutes left, Tony. This is 2 hours and 50 minutes. There's 40 minutes. Let's do some more problems. And all the students started laughing and were closing up their books as I was writing the problem down, and then
Well,
it
anyway,
dawned
let's
on
do
them.
this word
Yeah.
problem.
Okay.
So,
Yeah.
you read it aloud with your mouth.
A woman has a taco stand. She found that her daily costs are approximated by C of x equals x squared minus 40x plus 660, where C of x is the cost in dollars to sell x units of tacos. Find the number of units of tacos she should sell to minimize her costs. What is the minimum cost?
Write down that function.
Let me write it down. That's what I'm
Be
doing.
thinking about, does that function open up or down?
X
Does it have a
squared
minimum or does it have a maximum? Because the problem makes it sound like it should have a minimum.
Let's see. There it is. Switch over. Remember I said if the A value is positive, it opens up. If it's negative, it opens down. What's the A value here, just for the record?
So it's opening up.
Okay, it's an assumed positive 1, so the graph would open up. What would we have if it opens up? Do we have a maximum or a minimum?
Minimum.
A minimum, that's what they want us to find. And where does that minimum occur? At the, it starts with a V.
Vertex.
Okay, we have a minimum at the vertex. Earlier I said these word problems are asked for maximums and minimums, so...
If you just do minus b over 2a and then plug it in, you'll be able to answer all of these word problems.
Okay, so... using our vertex formula, which is also the axis formula, what's b?
It's negative 40.
A negative 40, so be careful. You already have that other negative there.
Be careful.
And A, what did you say A was?
1.
Okay, it's an assumed positive 1. I agree. Oh, this is working out
So
nicely.
40 over 2 would turn into 20.
Okay, 40 divided by 2 is 20.
If you had wound up with a negative number there, I think that would have been a red flag, because X in this one is, what, tacos?
The number of units of tacos. So
Yeah, you-
really X shouldn't be negative for her
She's
cost
just buying
function.
20 tacos.
So
Well-
that's going to minimize her cost if she produces and sells 20 tacos. But
Who knows what a unit is?
yeah,
It might
a
be 3
unit,
tacos.
a unit may be a dozen. She may need to produce and sell 240 tacos,
But
okay?
over
But
that unit.
that's 20 units of tacos. So her costs are minimized.
Oh, you're writing a sentence. Okay.
Oh, yes. When she produces and sells, I'm just going to say sells, 20 units of tacos. Realize that's not $20. If we want to know how much it's going to cost for her to make those 20 units of tacos and sell them, how would we find the actual cost? What would we have to do?
What's that minimum cost?
Put it through the equation.
Okay. So the first question that asks how many tacos should she sell? 20 units. Now they want to know what is that minimum cost. So we come up here, we plug in 20. Her cost, when we plug in 20 for X, is equal to 20 squared minus 40 times 20 plus 660. So it's 20 squared. I bet you, Tony, will open up the calculator, but we've been doing this stuff without it. So
400
that's 400.
minus 800
Minus 40 times 20, I agree, is a minus 800.
plus 660.
So that's what, a negative 400 plus 660, I agree. It's going to cost her $260 to run her taco stand. Now that's not how much money she's making. That's how much she's spending to buy the taco supplies and
Pay for labor.
pay for labor. If she has an assistant at the taco stand, that's her cost. Hopefully she's selling them at a price that's high enough to make up her cost and still give her a nice profit. It can't be just 20 tacos. It can't be.
Unless they're really, really, really lavish tacos.
At some place like let's see,
I don't know. But
Nimpas in Houston, so overpriced or
okay.
something
Because if
like
it's
that.
costing $260 to make just 20 tacos, oh wow.
She's got trouble.
$13
Yeah, she's going to have to be
per
selling
taco.
them. Yeah, she's going to have to sell them for well more than $13 a
Ratios is
taco.
$13
So-
for a big old breakfast taco.
Yeah, so maybe it's a huge taco, or maybe a unit. Let's hope a unit is maybe a dozen tacos.
That's what I was
Wouldn't that
thinking.
be nice? But enough of tacos. Let's move on to the next word problem. Oh,
The number of mosquitoes, M of X in millions, in a certain area depends on the June rainfall, X in inches. The function that models that phenomenon is M of X equals 24X minus X squared. Find the amount of rain that will maximize the number of mosquitoes, and what is that maximum number of mosquitoes? So let me write
I
that
just
down.
wonder why anyone would want to maximize the number of mosquitoes.
The
Well, I've read
no
a book.
reason other than just they want to suffer.
Okay.
Well, I read a James Bond novel in the 90s written by Raymond Benson, and wasn't he the bad guy trying to spread plague through mosquitoes?
Yes. So this was his
Some
problem.
diabolical mastermind was trying to maximize the number of mosquitoes.
Well,
Was it negative 24 or positive 24?
I don't know. Let's look and make sure I didn't miscopy it.
Okay, it
No,
is just
okay.
positive 24. I
Okay.
thought it was negative 24.
but
Be careful. What's A in this case? What number is A? A is the number in front of X squared. It's not just the first number. It's the coefficient of X squared. So I agree.
I'd
A
be
is
right.
equal to -1. I'm going to say right there, note A equals -1. So opening up or down?
Down.
It's going to open down.
Does this parabola have a maximum or minimum? Maximum, where does it occur? At the, it starts with the V, vertex. Okay. So we're using our vertex formula. X equals negative B over 2A.
So it's negative 24.
Okay. And good. Realize that A is the number in front of x squared. B is the number in front of just the plain x term. A is the number in front of x squared. B is the number in front of the x term. So I agree. B is 24. So we have the green minus or green negative from the formula and a 24. And what have we got right here? The A value?
Negative 1.
Negative 1.
So it's negative 24 over negative 2, which equals to positive 12.
I agree. Negative 24 divided by negative 2. And that's not, what is that, million?
No, that's inches. That's how much rainfall.
That's right.
Rainfall.
Wow.
So rainfall.
So a foot of rainfall.
So 12 inches of rain will maximize the number of mosquitoes. I always thought this problem was sort of crazy because it was my understanding that in warm weather, the more rain, the more mosquitoes. Are you telling me that if we have 12 inches of rain, as soon as we go over that 12 inches, what's going to happen? They start drowning or what? No, because according to this problem, after 12 inches of rain, the number of mosquitoes start falling.
But Tim, this is just a made-up problem. Do not diagnose mosquitoes based on your algebra problems.
Tony, you have absolutely no fun. You are absolutely. So it takes 12 inches of rain. How do we determine the number of mosquitoes we'll have if we have 12 inches of rain?
By putting that 12 in the equation.
Okay, so the number of mosquitoes when we have 12 inches of rain is 24 times 12 minus 12 squared. 24 times 12, is that 288? Someone check my...
No, it's right, because if you think of 24, it's 2 times 12. You have 2 times 12 times 12. 12 times 12 is 144 times 2 is 288.
Minus here.
144.
Ah, look at that.
So
There's
144 million mosquitoes.
Yes. I think that's what happened when we started getting that rainfall. At least that's what there was in Huntington Park. There had to be 144 million mosquitoes then.
That's what it felt like.
Yes.
Let me see. So all you punch in is 144.
Scroll down.
So with these word problems, if you just do minus b over 2a and then plug it in, that should get you the answer. Let's try this last one.
If an object is projected upward from ground level with an initial velocity of 144 feet per second, then its height in feet after t seconds is given by s at t equals negative 16t squared plus 144t. Find the number of seconds it will take to reach its maximum height. And what is that maximum height? Oh, look at this. So we don't have an x here, do we?
Yeah, the t.
I was going to ask him what variable is acting like x, but you cut to the punchline, didn't you? Okay, here's a function like this is called a position function, and it has important applications in a physics environment.
For us, it's just
Or a calculus problem. I mean, a calculus involvement, there are interesting applications for position functions. But for us, it's just a algebra problem. As I said, what letter is acting like x? T, okay. What's my leading coefficient? Negative 16. So do we expect our parabola to open up or down? It's going to open up, okay. No. I mean, no, it isn't. It's negative, so it's going to open down. And So if it's opening downward, will we have a maximum or minimum? A maximum, and it will occur at the, okay, the vertex, okay, and the vertex is determined using the axis formula. So we have x equals,
T equals,
thank you, Tony, negative b over 2a. What's b? Okay, remember b is the coefficient of the unsquared variable, so 144, I agree. And what did y'all say a was? Negative 16. So we have a negative 144 divided by negative 32. And that's not going in evenly, is it? 32, is it?
no.
No, it doesn't.
No.
Now, this is in terms of seconds, so I like that use of a decimal value. Negative 144 divided by negative 32. The t is in seconds, so 4.5 seconds, 4.5 seconds. That means the object went up for 4.5 seconds. It got to the high point, and then what did it start doing? It started dropping back down to Earth. So it took 4.5 seconds for this object to reach its maximum height. How do we determine that maximum height? What are we going to have to do? Once you know the first coordinate of the vertex, to find the second coordinate, you plug it in. So, let's see. The height after 4.5 seconds, so you plug it in 4.5, is negative 16 times 4.5 squared plus 144 times 4.5. And this one, this is something I want to do with my calculator. After bragging a moment ago, we were doing this stuff in our head. I'm going to let Tony punch this into the calculator. 144 times 4.5.
I could have just said times, but I'm putting parentheses to make it look like what you wrote.
Oh, okay.
And let's see.
324, is it feet or meters? I think it's feet. So this object went up in the air 4.5 seconds. It got 324 feet in the air, and then it started returning to Earth. Any questions there?
Any questions or comments?
Hey, we only did one problem using the graphing tool. Y'all want to do another one? No? Yes? Yes, let's do number 10. Let's go back to, or number 8.
Oh, okay.
Yeah, let's do number 8.
Number 8.
Oh, yeah. So we want to graph the quadratic function f of x equals
Negative 10 over 2
plus. Let me write the problem down first. Okay, f of x equals, and they're going to want the. You know what I'm going to do right here? I'm going to make a note. They want the vertex,
The
axis, domain,
and range.
and range. Are you going to take over?
Oh.
No, you don't have. This thing is working. I don't want us to move it. So I'll keep on. Okay. When I look at this function, do I expect my parabola to open upward or downward?
Upward, because x is positive.
Okay, the coefficient on x squared is positive. It's a positive 1, so we expect the graph to look like that when we're done. We use our vertex formula, x equals negative b over 2a. What's b?
Negative 10.
Well, it's just a 10, but that, okay, that purple negative from the formula makes us have a negative 10 on top. And what did you say a was?
1. So it's negative 10 over 2, which equals to negative 5.
Negative 10 divided by positive 2, I agree with negative 5.
And that's the vertex.
So that's where the vertex is going to occur. And
since we know what the vertex is, don't we also know what the axis?
we know this little blank right here, I'm going to fill it in. The axis, I'm going to write x equals negative 5.
And the vertex is just made of
No, it's a negative 5, but the vertex is an ordered pair.
Infinity.
No. What do we do to find the ordered pair? Jacob's in a hurry to get out. He's ready to... He's already taken that quiz, so he's thinking to himself, he has the day off on Thursday, so he's getting anxious.
I'm also trying to rush because my buzz is just
Oh, well, you just stand up and go, okay? Okay. No, don't miss the bus. Don't miss your bus. So what do we do to find the y coordinate?
Plug it in.
Okay. So we have negative 5 squared plus 10 times negative 5 plus 21. That's 25 minus 50 plus 21. 25 minus 50 is negative 25 plus 21 gives me a
4. Negative 4.
negative 4, I agree. So the vertex is the ordered pair, negative 5, negative 4.
That's what y'all were doing on those word problems. Find the x value of the vertex, plug it in.
Okay, now we're going to have to draw the graph, so we need another number. We choose a secondary point, a secondary x value. I like to use 0. But if I use 0, what am I going to get here for the y value? I bet you it's not going to give me 21 units on the y-axis. So my advice, don't move far off. Isn't this where the other vertex occurred on number 9? Did it occur at negative 5 also?
Yeah, because we also did negative 3 for it.
So we use negative. Why don't we use negative 4 here? Just choose an x value close to negative 5. So I'll use negative 4. Plug it in, negative 4.
So the first one is 16, it's positive 16, then negative 40 and 21.
So that's 16, I agree.
Then it's
Minus 40.
then plus 21.
Let's see, 16 plus 21, that's a 37. Minus 40, I'm getting a negative 3.
Yes.
Let's start typing in these answers.
The order pair negative 5, negative 4 is the vertex. Oh, they want you to draw the graph before the axis.
Now we're in a... Oh my gosh.
Yeah.
Oh, we.
Okay.
Okay.
So I'll click the vertical parabola tool right here. And I have to plot the vertex. What did we say the vertex was?
Negative 5, negative 4.
Negative 5, nope.
Negative.
There, is that it?
Yes.
Okay. And now I need that second point that we found.
Negative 4, negative 3.
Negative 4, negative 3. Negative 4. Is that it?
Yes.
Save it. And notice it looks a lot better there. Okay. Check answer. Okay. The axis.
X equals negative 5.
Okay. Now the domain, that's something here, I could have written that in without, as soon as I drew the little blank, I knew the domain. What's the domain of the function? It's a quadratic function. They all have the same domain because there are no fractions, no square roots. The domain is, okay, negative infinity to infinity, all real numbers. But for the range, you have to look at the graph. Negative infinity, comma, infinity. Okay, now let me see something. Let's see if we can get a better looking picture of what, let's see. Let's see this. Okay. I think that's better than what we have. Okay, there it is.
Would the range be bracket negative 5, comma, infinity, positive infinity?
Not negative 5. What's the smallest y value? What is the
Negative 4.
The y value at the vertex is negative 4.
Negative bracket negative 4, comma, infinity, parentheses.
That negative 4 is the smallest y coordinate on the graph, and then every number bigger than negative 4 is used. So I agree, bracket negative 4, comma, infinity, parentheses.
And before y'all leave, just once more, I want to make sure it's clear that on Thursday's class, what we'll be doing is, if you're using a Chromebook or any other device that you can't get that Pearson lockdown browser installed on, bring it to school. You can log into the college Wi-Fi, and you'll be able to take the test or quiz, whichever one you're ready to take. If you're not ready to take a quiz or test by Thursday, don't panic. We're going to have more of these days throughout the semester. In fact, I'm hoping to have a lot of them after Thanksgiving. If you haven't taken something...
Well, not that many. We don't have many days left after Thanksgiving. Only about 3 days.
Okay, you're right. But I think even the week of Thanksgiving, we'll have that.
That's assuming I'm not off, on medical.
Yeah, I know.
Something.
So let's just hope that we stay on schedule. Okay? So if there's any questions, we'll answer them. I'm going to stop the recording now. We'll either see you on Thursday with you taking a test in here on your own device.